you know, it could be distracting. People could lose power. I don't know how these things work. I'm from Georgia, for God's sake. Okay, so let's go ahead and canvas. So, right, you've got the, so this week is the beginning of module 3. Okay. So let's go ahead and just pull up what we've got here. Pages. Oh, right, modules. That's what I need to do. Modules. Okay, module 3. I'll be working on making some quizzes. So first off, your Arraylists are due in a couple days. We'll be going over one of the Arraylist exercises. But for module 3, honestly, this is a great week for it. Yeah, the overviews I don't really fill out because it's always the same thing. There's videos, there's quizzes, and then there's exercises. I'll be posting some quizzes. I'm just trying to put them into the new format. Your Big O exercises is a worksheet. It's a math worksheet teaching you a bit about Big O. Oh, yay, I did submit it. Yes, it says CS 5016 on it, but that's okay. Let's see. Please look at the above. Where is the... it's in the wrong place for some reason. I'll have to fix that PDF. I rendered very poorly. But anyway. This one's a bit different. But this one is I mean, this one you get to do a puzzle from a kid's book though. It's fun. Trust me. Anyway, we've got a bunch of pages here. Most importantly, though, for each of the method is this question over here. For each of the methods you wrote in lab 2, figure out the time complexity of the method you wrote. To turn in this portion, attach a printout of the code and specify the time complexity of each. So basically, I don't really care how you fill this out. It could be a text file, could be a document, could be a PDF. But you know, make it something that's pretty easy for me to open. And not say like 12 JPEGs, because that would just be frustrating. But regardless, you know, just fill in what you want. Fill in what you need. It shouldn't be too bad. For demoing this, mainly that's just me making going through the paper and making. Good one. All right. So the demoing process is me going through this and basically saying this one's wrong, fix it. Okay. So there's no reason you shouldn't get 100 on this one if you demo it to us, because I want to make sure that there's no point in you turning it in and me saying it's wrong and then you getting 10 points off on a question because you misunderstood it. That's not a learning experience. A learning experience is me saying, no, that's wrong. Go back and fix it. Okay. So that's the way this one is going to work. Understand? Okay. But this week is going to be fairly light. Next week, you'll have your choice of 2 different assignments. The exam, it says February 17th and not published. Don't worry about that yet. We'll figure the exam out based on how people are doing on one of 2 assignments I'll be posting here. Okay, now with that said, I did say that I would be going over the one of the questions from our Arraylist assignment. I said that basically that the permutation one is one that we are going to go over in class, but please try it on your own. And again, as a reminder, extra credit is available. Since right now you've got time to do it, why not take the time to teach yourself regular expressions? There's no due date on it. It's worth 15 points of extra credit. So the assignment's worth 0 points, but you can get 15 out of 0, which means 15 assignment points are just added on top of everything else, which makes it great. You can do it in any language you want. Let's see. So let's go ahead and pull up the list functions one. So methods and strings, right? So over here, let's look at this one, is permutation. Write a method called isPermutation, which takes in two lists, each of which contains the same type. It returns true if the permutations of each type of each other, and false if not. So what are permutations? They are permutations if they contain the same elements, including the same number of duplicates, but they don't have to contain the elements in the same order. So 1, 2, 4 and 2, 1, 4 are permutations of each other. AAB and BAA are permutations, right? ABA and AAB are permutations, but BBA and AAB are not permutations. They have different numbers of A's and B's. Make sense to everybody? All right. So let's go ahead and get started on this. Let's see. So public, let's go and first do this. So this is a true false question. So public static, because it's a static method here, Boolean, and we're going to take in, and yes, we'll need to make it is permutation. So there's tons of stuff here. There's tons of stuff on how to work it. We're going to go over 3 separate solutions for this, actually, each of which are increasingly weird or different. They basically, all my solutions here are very different. It is very hard to type with gloves and an ergonomic keyboard that you're not fully used to yet. So list E. Okay. And now let's go ahead and say, since there are lists of the same things, right? We've got those. List A and list B. Now, some people have done so. I have done this by going through and iterating and removing and basically zeroing out either A or B or both of them. Somebody asked, what about ABC, ABCD? Those are not permutations. Those are not permutations because the first item doesn't have a D in it. In fact, one of the requirements that's very easy that we can easily put in is that if they're not the same size, sorry, I have to remember how to do, if statements in Java after working in Python for like forever. If A dot size is not equal to B dot size, so if our 2 lists are different sizes, we can just automatically return false because it's impossible for them to be permutations. Okay, your solution should not have a great sign complexity for this, actually. The fastest you can get it is O of n, but you're going to be using up a bunch of space complexity as a result. But we'll see. I'm going to be writing first off an O of n squared, then I'm going to be doing an n log n, and then I'm going to be doing an O of n solution. Both require increasing amounts of knowledge that you do not have. So now I like to be very straightforward in my answers. So by default, what we're going to do is return true. Basically, we're going to assume that these things are permutations of each other. And as soon as we can prove that one isn't, that they don't match, we return false, essentially. So that's the way you approach writing Booleans. Basically, make an assumption and try to prove it wrong. And try to assume what's harder to prove, right? So it's easier to show that these things aren't permutations. So I'm going to assume that it's true. So what I'm going to do over here is I'm actually going to do a for each loop because those are easier to write. And I'm going to do this without modifying either of these. So for E item in Python, you use the in keyword. For each E item in A, and this is going to be rather silly. Okay, this is why I say there's really awful solutions to this. So what I'm going to do is that for every item in A, okay, I'm going to count the number of times int count A is equal to 0, int count B is equal to 0. I'm going to count each the number of times each of those appears in each list. Notice that even though I've seen this item once, I still set count A to 0. And this is because I need to actually know what I'm counting before I can count it with the way I'm going to set it up. So, so for every item in A, I'm going to count the number of times that appears in A and the number of times it appears in B. Okay. And I know that basically that this has to eventually work. Sorry, and this line over here is actually going to pull a lot of weight here because this line prevents me from from getting cases where like there's an ABC and ABCD, right? Where I go through all the A, where I match all the A's, B's, and C's, but don't bother matching the D. Because they're different sizes, I would never even get into that. So, okay. So here's where it gets messy, in my opinion. For E, actually, I'm going to go ahead and just do it like this. For I, 0, so for E, I is equal to 0, I is less than A dot size. So for each item in A, iterate through all the items in A. Sorry. If A dot get I dot equals our item over here, count plus plus, count A plus plus plus. So I iterate. So for every item in A, I'm going to go through A and count all the times it appears in A. And then it actually gets pretty straightforward after that. For all the items in B, if B is, if I get the item at that index and B is equal to that item, I increment B. Okay. By the way, I say that this is N time complexity because it's, some people would argue, oh, it's N times M or N because, you know, you have two different lists that could be of two different sizes. But this first line basically says, if they're not different sizes, it's a constant sign solution. It's going to, you just simply throw it out. So we get to assume they're the same size because if they're not the same size, it solves itself very quickly. Okay. So for every item in A, I count the number of times it appears in A, count the number of times it appears in B. And then all I do is say, hey, if they don't match, if count A is not equal to count B, get out of here. Return false. Okay, and then I get through and I'm done. Okay? Make sense to everybody? Okay, so again, the times complexity of this one is O of n squared. And the weird thing that happens in this one is that I'm iterating over the same thing inside an iteration of, sorry, I'm iterating over something inside an iteration over that same thing, which makes it kind of weird, but it's one of the more easy ways, albeit messy, kind of unorganized ways to do it. It's actually, well, not unorganized, it's just counterintuitive. Now, there's other ways to do this, though. One thing that I'm sure a couple of you had the idea of, and I know somebody asked me, and I get typically more of these kind of questions when I'm in person and people can ask me immediately, is I'm trying to sort this. Why can't I sort this? I mean, yes, 2n squared, but we always just say n squared. It's the 2 doesn't matter. It really doesn't. So so let's go ahead and start over here with is permutation 2, right? So this is going to be my second method, and I'm going to solve this one by sorting. Return false. Okay, and then, sorry, return true. And in fact, I'm going to copy this very same first line because this first line is pretty much universal. Well, because it just makes it my job so much easier. If they're not the same size, it's not a permutation. We're done. Okay. But the way this one works is that I often get people asking me, hey, wait a second. I know the collections. There's a collections package in Java. In fact, there's a collections.sort thing. So can I just sort A? Right? Now, why would you want to do this? First off, let's go back to why you want to do this before we go back to the how we want to do this and address that error. Okay, so let's suppose that our permutations are we're checking two lists of letters, Flo and Wolf. If you sort the letters, they both sort to if we sort these in alphabetical order, they both sort to the same word. In fact, any kind of thing, any kind of permutation, be it a word or something, if you sort it, it's going to end up being the same, right? So, for instance, if I do 1 3 4 2 5 and 5 4 3 2 1, they both sort to the same list, right? They'll both sort to 1 2 3 4 5. Make sense to everybody? Everybody following this? Because this is important, right? Okay, I see a thumbs up. That's great. Okay. So again, if you need me to slow down, you can direct message me or something. So, or you can just shout in chat. Either works. So if A dot size and B dot size, if they're not the same, maybe we can just sort them and figure it out. But when you may have tried this and then it said you get this error saying, hey, it's hard to see. It says, hey, no instance of variable type T exists, so E conforms to comparable T super T. And you're like, what in the world is that? And why is there a question mark? I'm done. Java makes no sense. It broke me, right? Maybe if I switch it to the same letter because there's T's. Nope, that didn't work. Now the error is just is even more confusing. So, okay. So first off, what the heck is a comparable? So let's go ahead and let me go ahead and actually give you the source code for that. Comparable, Java, and I'm going to drag it over to the screen in a second. Source code. And one of the issues when you write is that you often type things what you're reading. So, okay. Looks like a lot of code, but let's go ahead and look through it. Looks like actually scrolling through, most of it is comments, actually. So source for java.lang comparable. You can do this for anything, by the way. You can look up the source code. So it's saying package. This is just saying that, hey, this is located in the java.lang package. Okay. Who the author is. We can blame this guy and this guy for this. Okay. So what is comparable? It's an interface that takes in a generic, meaning it's taking something. And the source code says what this does is that it compares this object with another and returns the numerical result based on the comparison. So this is an interface specific. Sorry, this specifically, though, is an interface for objects that can be ordered among other objects. The ordering can be total or it can be partial. So in other words, this basically, then that's a mathematics kind of thing. Okay. So the that's a set theory kind of thing, this total or partial ordering. But basically it's saying that if you want things to have an order, you got to have the comparable interface. Why is that? Because you got to be able to compare things and say, hey, one is less than, one is greater than, or they might be equal to, in order to make sure that things can be put in order. For instance, integers are comparable. You can put them in order. Strings are comparable because you can sort them alphabetically. Anything that can be sorted is comparable because things need to be able to be compared with, right? So it is a method that has only one it is an interface with only one method, compare to, which simply says, given another object that's also comparable, I want to make sure I'm going to return an integer. There's three rules basically for an integer. So let's go ahead and go to main for a second and see how that works. Okay. So we're going to work with integers for a bit, as well as so again, I've mentioned that integers are comparable, so they have the compare to method. Okay, so let's go with let's work with strings because I can just directly cast them. So apple dot compare to apple. So here I'm comparing one word to another word. Same word to a same word. Run it, and you'll see the answer I got was 0. So first off, again, compared to returns an integer. If two things are the same, if they are equal, then this will return 0, right? If they have the same value, then one thing compared to another thing will return 0. Okay, so let's go ahead and look at maybe let's go with integer x is equal to 17. Integer q is equal to, I'll go with y. Why confuse you? Integer y is equal to 20. X dot compared to y. So here we're taking a smaller value and doing compare to there. So we run it and we get -1. Doesn't have to be -1. It could be, as we'll see with strings, they'll actually be something. It'll be do something else. But basically, if you've got two things, x and y, and you're doing x dot compared to y, if x is smaller or comes before, you'll get a negative number. Okay. Similarly, if we do y dot compare to x, the opposite, if we do bigger dot compared to smaller, or we say thing that comes after compared to something that comes before, we'll get a positive number, right? A positive number for saying it comes later in the ordering. Okay, it makes sense. So you get a negative for smaller or before, and a positive for bigger or after. Now, why do I give you that caveat? Because let's go ahead and go back to our this example. Apple dot compare to aardvark. In case sensitivity does matter here, but I want to just keep it simple right now. So let's go ahead and run it. And notice that we got 15 back. Not 1, but 15. Now, first off, aardvark has 2 A's. Apple goes AP. So alphabetically, aardvark comes first because A and A match, but A comes before P. So aardvark comes after Apple. Sorry, Apple comes after aardvark. Aardvark becomes sooner in the dictionary. This number is kind of the distance to there, but it's a positive number. That's really all we need a lot of the time when we're doing comparisons. Similarly, if I did aardvark compares to Apple, I'll get a negative number, most likely -15. Okay, makes sense? Keep thinking I'm hearing breathing. I'm wondering where the cat is. So, okay.
So do you get a negative number with aardvark because aardvark comes before it in the dictionary?
Yes, alphabetical order.
All right.
So in order to sort something, so now let's go back to this error that we had over here. Collections.sort. We get reason, no instances of type T exist that conform to the comparable super T. This is saying that we cannot guarantee that this T here, which I'll switch back to E, we can't guarantee that this is comparable. For all we know, we could be trying to do a list. We could be handled a list of servers or a list of scanners or something that might not be, naturally comparable. Make sense? So what we can do in this case is that we can actually do some magic over here. What on God's green earth did I just do? What I did over here was saying that the generic E here, I'm placing a rule on it. It has to be of the subtype comparable. And furthermore, those comparables get compared to other E's. So in other words, things that are comparable to themselves and only themselves. So, but that's, I mean, there's other better way. There's other ways to do that. I believe they're like, this is the way it wants. Sorry, not extends. Super. Which is more than we need. Again, that's bringing nuclear weapons to a knife fight here. So, but we can get into that later. But right now, basically, this is enforcing that these lists that take it, these lists over here, they have to take in a comparable. So it has to be integers or doubles or strings. It can't be scanners. So a bit less useful, but it runs faster because now what we can do is we can say, hey, collections.sort, and let's see, does it return something? Collections.sort returns a void. So we just sort A, we sort B, return A dot equals B. Now, mind you, we did just alter the order of A and B, but we can, of course, if we really needed to, we could take O of n time to clone A and O of n time to clone B into new lists and then sort those lists. Now, how long does this one take? Well, sorting takes, how long? Well, sorting takes n log n. When it's that's how it's implemented in most it uses an n log n algorithm in most of in most in most programming languages. So here, I'm wondering if it says, but most of the time these days you're using timsort or quicksort for your sorting algorithm. Okay. So rather than, now, mind you, doing this quicker would be a bit, doing this one specifically quicker is a bit, it looks just as messy as this, if not more messy. So instead, what I'm going to do, I think, rather than going over a third solution, I'm going to go over one of the other problems. Let's go ahead and grab the Arraylist exercises over here again. I'm just going to go and look over one of the more simpler ones we had, which was uniqueness. So let's write a method called unique, which takes in a list and returns true if all the items in the list are unique. All the items are unique if none of them are the same. Returns false otherwise. So, okay. So you probably ended up doing something like this for that one. So public static E Boolean, assuming I can spell. I'll learn how to type one of these days, okay? I promise. So here's a list. We want to know if all the items in it are unique. And you probably wrote something like this. For each item in this, let's say in list dot size. So for every item in it, E item is equal to list dot get that item out. And then for int j is equal to I plus 1. J, and this is one of the places where even I still make mistakes. very much my fingers want to say I is less than list dot size, but that's a great way to do an infinite loop. Of course, what I really want is J. So just very easy to do that. Just keep that in mind. It's a very, very easy way to when you write it, when you're doing nested loops to get an error. Okay. So E other is equal to list dot get J. Now the reason what I'm doing is basically saying for each item, check all the items to the right of it and see if they match, which is what I'm about to write over here. If item dot equals other, return false. And then if we get through all the checks, return true. This takes O of n time because, O of n squared, because we have to check every item against every other item. Does it need to be list minus size minus 1? Yes. Another error that's very easy to make. So this will hit everything in it. Trust me, it works. Or it should work. Now, the other way I can do this is that I could do it like this. I can write. No, I don't want to drag that space. I want to drag this. Okay, give me this. Don't care about that for loop. Return. Let me go over here. Java.util. Hey, I'm just going to import everything just for speed. Of the sake of speed when I'm running when I'm writing this. So yeah, return equal list.size. Return new hash set list.size equal. There we go. E is already defined in example. Where did this go wrong? Where did I go wrong with that? Excuse me. That is an error I'm not experienced with. E is already defined in example. E extends object. Where did I do that? Or is it because I did that here? That is weird if that is the case. Public static unique. Oh, okay. Right. It's not the E, it's the unique. Silly me. Unique 2. And so this magic thing will do that. Same thing, and I'll do it in O of n time, which is cool. Maybe I should probably explain what's going on here, though. So, first things first. What I'm going to do solve hash set in linear time, O of n time, meaning I'm only going to check every item once, is as follows. I'm going to use something called a set, which is something we'll learn much later in the semester, but why not right now? The basics of it are very simple. If you know what a mathematical set is, you know what a set is. Congratulations. If you don't know what a mathematical set is, it's a collection of items. Order doesn't matter. And you can only have one of each item in it. It's great for doing stuff that involve like checking, basically checking, have I seen this thing before? Or checking if there's like, if you know, it's been included. So return true. So what I'm going to do is I'm going to write this as, so here I've got this hash set. And what I'm going to do is simply say for E item in the list. So for every item in the list, if set, and I'm going to just simply do this, even though it's repetitive once you know sets, I'm going to do it like this. if set dot contains item, sorry, if the set does not have the item in it, add the set. We're going to go simply and say set dot add the item. So we haven't seen this item yet, add it to the set. Otherwise, return false. And that's it. So the key here is that this contains over here takes constant time, meaning it doesn't matter how big your set is, it will take the same amount of time to check it. Same with your add method. To add something to a set takes constant time as opposed to, say, linear. Why? Black magic, that's why. Inscrutable arcane magic, that's why, which we will be learning later in the semester because of the way hash tables work. But all you have to know is that because this takes linear time, it'll work really quickly. And same with the add. And if it already has it, well, it can't be unique, so return false. Again, this will run very quickly. So, however, as we will learn, nothing is without its cost. In this case, we will be sacrificing our computer memory for time, which is less of an issue these days, but used to be an issue, and is an issue for small devices that don't have much memory, especially if your list contains like millions upon millions of items. So, you got to ask yourself, which do you value more, the time or the space? And that really depends. But usually the answer is that we value time more than space. Okay. Why do we value time more than space? Why do we measure big O in terms of time? Why do we care about how fast things run rather than how much memory it takes?
Because you can mitigate space concerns, but you can't really mitigate time concerns.
Mm-hmm. Or to put it the way I like to put it, yes, George has got it because I think he watched the videos, or he's just got the same thought process. You can't buy time, right? I can go out and buy more RAM. In fact, I have. It's pretty cheap these days. I currently have 48 gigabytes in this. I did not mean to give you an existential crisis. You can go out and buy more memory. You need bigger battery power. That's another cost we care about, by the way. It's acceptable for things to run slower on your phone a lot of the time if the battery will go correspondingly for a longer time, right? Apple actually got a lot of flack a number of years ago for forcing an update that that would drain the battery life. It was either that it would drain the battery life faster or it slowed it. I think it's because it slowed the iPhone down, the older iPhone model down to extend the battery life. Right, that's a kind of cost. But time is the most important thing because, again, you can't get more of it. You can't go out and say, hey, I'd like to buy 10, years or something. Although I did read an interesting short manga about the idea of you could go out and sell your lifespan, which was very interesting.
Couldn't you buy a faster processor?
You could buy a faster processor, but you can't. But that only goes so much, right? And that only scales so well. Faster processors don't really. The cost of buying a faster processor is you have to wait for a faster processor to come out. Because, I've got a pretty fast processor as it is. So, but let's see. Task manager. Yeah, so I've got this second generation AMD Ryzen 7. It's got an 8-core processor with 16 logical threads, meaning you can think it's 16 different computer cores at once. That's pretty cool. But there's only so much speed it can provide. Right. I'm not really going to get too much of a I only am going to get so much returns by going and buying a okay, so I could go out and buy a Threadripper and get something like twice as fast. But what I cannot do is I cannot buy a processor that's going to lower the order of magnitude for of the amount of time it's going to take to run, right? It's not going to run square root less time. But with memory, you know, that's fairly, like, I haven't even maxed out this computer yet on memory. I've still got plenty of space to spare and plenty more RAM to buy. It's much easier to go and buy more memory. Oh, and if your computer runs out of RAM, by the way, you know, it's got all this much slower memory it can use over here. It can, that's what the page file is. Or, you know, that's what the swap space is in Linux. So it can rely on using your hard drives. You know, that movie, I believe it started In Time. I believe it starred what, Justin Timberlake, I believe. Was that right?
Yes.
Yes, I just Googled it.
Yeah. Okay. So they missed out on a great chance to just call it Just in Time.
Ooh, true.
Yeah, that's my top criticism there. I know. The manga was more of a romance, though. It was pretty good. So, all right, let's go ahead and stop my share. So, okay, any question? So hopefully that helps you finish off that problem, as well as shows you a different way to do it. We'll be introducing sets much later on. They are super awesome. And and hash maps are even more correspondingly awesome. They're used for counting things, which works for the permutation just great. All right. So are there any, I know we only really have half an hour left, but if people want to work on their stuff, I'll open up breakout rooms. And I assume people want a demo. So I'll go ahead and also take demos. But first, are there any general questions that people have that they want to ask, or questions that that are specific to them but think other people will benefit from?
I have one of those. So in my let's take an example, in my all multiples function. I'm creating an output list, and then I'm adding an element from the original list to that. Do I have to clone that element?
No, you do not. So that is an excellent question, because you're dealing with lists of integers. And when you add an integer to the list, it should just create a new int, really, to put in there, as opposed to like creating a pointer to the old item. Okay? So we can
Gotcha.
I mean, that's a great question. It gets into, wait, when are we dealing with these things and when are we not? So, right. Or when are we dealing with objects and when are we not? So here, right, if I do list, so let's check this out. List integer list is equal to new array list, right? No problems there. Just going to make that, and we're just going to add list.add x to it, right? So I'm adding it to it, and I think the question you're asking is, fundamentally, what is the output, right? Is that the fundamental question you're asking?
Yes, that would answer it.
All right, so let's find out. 17. So the answer is no, you don't have to clone it. Adding an integer, a primitive, or a boxed primitive, which is what an integer is, adds a new item. It adds a new integer, right? So you don't need to clone anything. In other words, you don't need to think too deeply about it, right? there's a lot of complaints that you can have about Java, but a lot of the stuff works in such a way that you don't have to think too deeply about it, as compared to, say, if you're working in C++, where you really have to think, wait, are these the same things? A lot of times Java took the solution, they implemented the concept of least surprise, meaning that the least surprising thing would happen. Any other questions? That was an excellent question, by the way. And that was one where I was 90% sure that I knew the answer. I should admit fully, I was 90% sure it was going to work this way, but there was a 10% chance. Where might not? You were muted? Okay. So let's go ahead. And that was an invitation to unmute if you wanted to speak. But all right, I'm going to go ahead and briefly open up. I'm going to open up some breakout rooms. You are free to go if you want to go, by the way. If you want to stay and work and ask questions, you can. Otherwise, it's a snow day. Like, go out and have fun or something. Okay.